All right, in this video, we are going to continue our lab on malware or dynamic analysis of malware, or also malware detection. This is the fourth video in the series. So the first one was the lecture of malware analysis. The second one was extracting features from log files. The third one was the machine learning part with Weka, and now we're going to analyze the data set with Sklearn. All right, so if you're following along with our lab handout, for this lab, you will have as your input, a file that has the extracted feature vectors already, log file features.csv. And you will also have some starter code. You should have filelist.sklearn.py. So this file already includes the libraries, and it includes any helper functions that you might need, so that we just have to focus on the basic part of the code. So if you remember, if you want to take a quick look at log file features, _features, so there it is. That's our data. Remember, it's basically just a frequency count of the common terms in the data set. Okay. So we're going to proceed to open the file list sklearn. So I'm going to do nano file less sklearn.py, and you can see here I've explained all of these libraries for the most part in previous videos, so I'm not going to go into it again. Just notice it has the main ones: sklearn, pandas, numpy, and then from sklearn is grabbing all the libraries that you need: random forest, decision trees, and so on. All right, once we have that, we also have the printstats metric function that I explained in another video, and this function is basically to do the statistics, right? Precision, recall, F-measure, confusion matrix, etc. All right, so now that we have that, the first step that we're going to follow is we want to read the file from the file system. So to do that, I'm going to create a variable feature, and I'm going to do gen from txt, and I'm going to read the file log file features.csv. All right, so that's my basic function, okay, for reading the files. Then I'm going to say that the delimiter is going to be a comma, and then I'm going to say to use the columns, and actually I'm going to move this down a little so that with a backslash, so that's easy to read. So I'm going to do use columns equal, and I'm just going to create a list comprehension of which ones I want. So I'm going to say for I in range from 1 comma to 1001. All right, so I read all the features. Remember, the first one in this range 0 is the labels. All right, once I've done this, I can specify the data type. I'm going to say this is equal to int, because these are frequency counts, comma. I'm going to add another backslash here, and I'm going to say to skip the first, skip header, skip the first row, which has the label names, or the heading names, column names, and close parentheses. All right, that allows me to read the data. Then I'm going to read the labels. So I'm going to do target equal gen from txt, and I'm going to read log underscore file underscore features dot csv. All right, so I read that, comma, delimiter equals, comma. All right, and then I'm going to say use columns equal 0. So I only specify that I want the 0 column. Oops. And I'm going to add a backslash. Okay, now down here, I'm going, now that I've read use columns, also specify the data type. So data type is going to be int, comma, and then finally skip header. So skip header equal 1. All right, so we skip again the first row. All right, so now that we have this, we can specify the labels. So the labels are already -1 and 1, but if we wanted to change them, we could. So I'm just going to kind of keep that consistent with previous labs and just change them. So I'm going to do labels, label encoder, and I'm going to do dot fit transform target. So remember, this is the example where if the labels were like goodware, goodware, malware, malware, we're going to change them to 1, 1, 1, -1, -1, -1, or 0, 0, 0, 1, 1, 1. So that's the approach here, what we're doing. Okay, once we've converted these, we can proceed to scale the data. So I'm going to do feature. So remember, scaling the data or normalizing, I've already talked about this, but in the lectures, I recommend this as a technique. So feature normalized, and that's going to be standard scalar dot fit transform, and we take as input feature, right, or features, however you want to call it. All right, so that allows us to scale the data here, right? So I've done it. And then finally, once we've completed this part, we can proceed and just do the split, right? So here I'm going to split the data. I'm going to do a 75-25% split, so I can have a train set and a test set. So I'm going to create X train, comma, X test, comma, Y train, comma, Y test. All right, and so we call our function train test split. All right, train test split, and we provide to it feature normalized, comma, backslash there, and we provide feature normalized, we provide the labels, comma, we specify that we want a test size equal to 0.25, and we specify a random state to be 0. Remember, we already talked about random state as well. It has to do with how we get the same randomization every time, right? So let me go back here. All right, so we have labels, we have test size 0.25, and then we have random state, and let's set it to, could set it to 42, you know, so you always get that, or 0, for instance, right? Now, once we have this, we are pretty much done with like the cleaning of the data, right? Our data is ready to go. And so we can proceed now to the machine learning part. I'm just going to do 2 classifiers. I'm not really going to do all of them. I'm going to do the logistic regression one first. All right, so I like logistic regression, so I'm going to try that one. Also, it's not one that we did in the WECA program, so let's do that one here. All right, so logistic regression. If you you might want to print out with your results that this is the logistic regression result. So I'm going to say logistic regression results. Okay, there we go. So now we can go ahead and just call our object. So I'm going to say log regression, something, log regression 1. I create the object. going to be a logistic regression. An object. Okay. Now I'm going to do log reg1 dot fit. So I'm going to train the data. So for this I need x train, comma, and y train. So I train the data, I fit the data. Then I'm going to do the predictions. So predictions, and that's going to be log. So this is log regression 1 dot predict, and we're going to predict on x test. And then finally we run the metrics, right? So I'm going to do print stats metrics, and we plug in y test, comma, predictions. So that's y test and predictions. So now we can go ahead and see our results. So let me add one line here. Print done. All right. So let's go ahead and run this code, see what happens. So I'm gonna change that to Python. All right, let's see if it gives us any errors. And it's giving us an invalid syntax error. Go back here. And that makes sense. I'm missing an equal here. Okay, try it again. All right, and that's it. So there you can see we run the logistic regression algorithm. The accuracy is 0.97, 97%. Confusion matrix, just one misclassification really. And you can see that here as well. All right, so that's the precision, recall, and F measure are all above 92%. So it does really well on this simple example. Let's do one more. So I'll do the random forest classifier. So go back to Nano here. And I'm just going to add one more. Okay, so this is going to be print random forest, and I'm going to create a random forest. I'm just say forest, a random forest classifier, forest dot fit. We fit on the x train, comma, y train, and then we have predictions, and we do forest dot predict. Again, pretty much the same thing. We predict on x test, and then finally we do print stats underscore metrics. We take y test, comma, predictions, and that's it. That is Sklearn with random forest. So I'm just going to run the code now. All right, and there you go. You can see now we have the results for logistic regression until here, right? Above 90, then we have the random forest. You can see the accuracy is higher. Basically, random forest actually did better than logistic regression. We can look at the confusion matrix, and there were no misclassifications, right? And so that concludes our video on how to do malware analysis using Sklearn for machine learning. In the next video, I'm going to now analyze the same data set, but this time we're going to use TensorFlow in our TensorFlow code. Thank you.